Plan for this particular impeller is basically it's been printed to scale. This is a 2-inch PVC pipe. If you put two of these and a 3/8 in the middle here, what ends up happening is you get between 1 millimeter to the internal diameter of a schedule 40 pipe. 2-inch schedule 40 actually, that needs to be said. So I've taken the 3/8 copper, cut them, open them out, split them and flatten them. Many moons ago, when I was in a different country, I had less equipment, I started off making these. So I've just gotten back now to trying to actually curve these. And as you can see, this first one is slightly curved. Not the greatest of curves, but I don't think anything much more than that is needed. The second and third one is still flat. So that's the first little piece of it. And if you put them together, you can see clearly. First one's curved, the other one's flat. My template for this, for cutting this, was a different fan blade. This is a different shape, slightly different as you can see. But notwithstanding, I'm using a fan blade. Now it may not be the best idea. Fans are meant to move while it's fluid air. This is meant to be a prop. But I'm working with that. I'm working with this angle here that I'm seeing. It's starting off relatively straight and it's twisting out like that. And that was, I think, 15 degrees if I remember when I measured it, somewhere thereabouts. That said, that's what I'm trying to achieve here. Start off with this relatively straight and curve up. So yeah, hopefully I get this other two relatively similar. You meant the grand method of curving this. Turns out spoons have a tin top and a tapered curved end, and it's relatively similar. So what I've done is take one of these tin nose vice grips. Grip the side that I consider to be the flat side, which is this side, the leading side. And then what I'm going to do is just press this again and roll it, and that is getting me the shape I have here. And the first one I took some time with the extra pliers and bent through. The second one I just rolled it, and they are actually almost perfectly the same. Just have to get them together to show that. Yeah, have a look at that. Almost perfectly the same. Very consistent. So yeah, this is a grand, I don't know what you call it, technique, but it seems to work. We just take that, fold it over and roll it. New plan is to use this piece of brass, which I just cut off with a hacksaw. This was a chop saw, clearly, from where I purchased it many years ago. Clean this up and basically mill a slot across. Take this shaft here, which I know for sure is not stainless. That's going to be fun. Probably take off this piece or use the other side, who knows. Anyway, and just face these two sides, so I end up with a linear, well, curve and a straight piece in the middle, which I'm going to try to replicate on this, and then thread the end of it so I can attach it straight on. We'll see how that goes. It's an interesting approach, but anyway, that hopefully works. As I said, this is definitely not stainless, so again, this would just be a trial, but it will not work in practice for any length of time unless I find some method of corrosion protection. Maybe copper plating it, maybe trying to nickel plate it. Again, still wouldn't last forever, but it might be better than just plain mild steel. So let's get on with it. Let's see if we can clean this up first, and then we'll deal with this after. This is the progress so far. We have the little slug turned out, and all I need to do is mill the correct distance there. We have the shaft turned 5/32 here and threaded M4 threads, and what we need to do now is flatten the edge and mill this. This will go all the way in, a little bit further in, somewhere about there, and then the nut will tighten on the end. So flattening that, milling this. Made. This has been milled out. It's looking quite nice inside there. 7.5 millimeters, 7 millimeters has been milled here. Eyeball. The first piece is easy to cut. The second one was eyeball. It doesn't fit in yet, and that we know for sure wouldn't happen because focus is off. When you mill this, the edges here are going to be, still 90 degrees, and that's a nice 5/32 curve. So the edges of this have to be rounded before this fits in. So let's get to that and let's see how well it fits. A little bit of file, it's gone in, it's in there a little tight,
2 light taps on this on the device and I'll get it out. But yep, I'm quite happy with this. This is pretty solid in there, and when I run up a nut, shouldn't come out, hopefully. Dodgy arrangement. What I've done is put one coin below, then one coin on this thing, keeping this edge flat and this edge raises, and that just supports it. It's barely supported, but I am going to try the silver solder. So the plan at hand here, run the torch in it, get it red hot, and get three little pieces of silver solder cut out, and let's drop them right in the correct position with the tweezer. We'll see how that turns out. Could turn out okay, could turn out not so okay. We'll see. I'm a little worried about trying to touch the silver solder because everything will move. Really, this should probably have been encased in something like possibly some clay to keep it fixed, or I don't know, maybe some cement or something to keep it fixed. Pretty good job of messing this up. The solder flowed all over when I tried to touch it because of the curvature. As the solder ball there, I can take that off. This brass started to melt, as you can see, and yes, we may have actually, but this one is definitely soldered on. I think this one maybe also. We will see if with the leverage I can pull them off and clean this up. It may or may not be salvageable. We shall see. Didn't turn out that bad. This one bent slightly because of that little joint there. This one is where the coin was attached, and I had to actually take it off, so I still have some finished areas. These are bent slightly, but again, it's not impossible to bend them back. Very easy actually, which means, yeah, maybe copper wasn't the best, but again, it was the material I had where I was located, and yes, it's not ideal for sure. But yeah, they're relatively stiff onto the hub. I think I'm going to mount this back on the lathe and possibly clean up this face slightly. As you can see, it has some damage, and probably take down this edge a little bit. But apart from that, yeah, it could clean up, looking barely acceptable, not great, but it seemed to have stuck on. It seems like it's soldered. At least that part of it seems to have worked to some extent. The back, I'm not seeing anything productive. I don't know how well it's held, and I did make a few pieces like this to put on top, so that it would have basically thing. The back is probably a better place to put that anyway. I'll probably end up putting that with normal solder, although silver solder is ideal thing. I think if I heat this up, these things are going to move. So, you know, unless I'm putting some kind of clay to hold it in position, that is probably not the best thing. If I do the clay to hold it in position and keep it firmly in position, just press everything in place and then just heat, maybe, just maybe, those extra pieces of copper are going to be useful. In the end, I've managed to put some clay underneath and put 3 pieces of copper wire, and then put quite a bit of silver solder. I am convinced this is not even slightly balanced, but yes, it should not be going high enough speed to be a major issue. I'll probably have to clean up that edge a little there, but beyond that, yes, this is the copper wire I used from one of those XLP cables. So yeah, hopefully this works. It looks like it's going to be a lot stronger with this now, and I did not screw up this side and overheat the bushing. Learning curve, now I know. Propellers that I want to test, as we've already gone through. This one with the shaft here, I just wanted to polish it up a little bit so it looks nice and shiny for display. This is going to corrode before the end of the day probably, so yeah, it's gonna get dull. That's what copper does, it corrodes and gets dull. I don't think this is strong enough. I think these are a little bit too flimsy. Maybe later on what I'll end up doing is cutting another piece here and putting some pieces of copper wire across and thickening these so they are a lot stiffer. But I am definitely very happy with the joint at the bottom here. These are not going to break off now, so that's perfectly fine. The top isn't that great, but the bottom, it came out well. What I did is I ran it up on the lathe to take off the little pieces that melted off this brass and I overheated it. As you can see, there's still 2 little digs, but not everything can be removed. So yeah, this design, which is based off a fan blade, again air, so it may not be the best, but it looks similar to a lot of what you see on big ships. Theoretically this works. M4, hopefully I can get an M4 nut or make up something. This is the other one that was done probably 6-8 months ago, actually more than 6 months, probably 8 months ago. This is a computer fan. I took it off, took out the inside of it, which is a metal piece and the plastic infused with magnetic particles to create the brushless motor. I've taken the what you call this? This is basically a gear, right? For a belt drive, actually not a gear. And this basically had the correct opening for a shaft already from one of the old printers, and I have that. So it's a matter of putting this in. It has the correct length, a circle clip on one side and a circle clip on the other side. So this is going to go straight in. You can see the little piece there. And what I'm going to do is test between this design, that design, see the differences. Of course, it's a lot more complex because this is a large piece with small blades, small piece, larger blades, different diameters. Direct comparison may not be possible, but again, what I will look at is really just efficiency. Power in to power out. Again, it's not directly comparable, so I'm not sure how that will work out in terms of comparison or whether it will be sensible. We'll see at that time, but I'm going to put these up and deal with analysis at a later date, because those analyses are going to take quite a while. Trying to even figure out how much flow I'm getting, that's a different story by itself. I'm not sure how I'm going to figure out flow. Force I can figure out, that is probably the easiest one to figure out, and that is still complex by itself because you don't really have a good method of measuring force, nothing accurate. So we'll see how it goes, but yeah, these are the two designs, two impellers. I quite like how this looks. While I don't think it will work very well for any length of time, I think the forces are going to cause this to flatten out and become very inefficient. But notwithstanding, I am quite comfortable now to take this same design and replicate it in brass with a thicker brass for here. Again, this came from a piece of copper tubing, 3/8, and that was cut and then straightened. So yes, the thickness was not something I was able to determine and or choose. It was just a matter of the material I had. So in future, again, what I will do is, if I replicate another one of these, I'm happy with it, and I replicate another one, it'll be brass and thicker brass here, bend again so that each tree has the same bend. I like the spoon method. I'm not sure if brass can work with that spoon method though, but this is what we have. So hopefully it turns out productive.